So in this video we will do the problems on searching. Okay, so how do we do problems on searching? So for the first problem which we are going to discuss is, suppose we have an array, like we can say like this, given an array of n numbers. Okay. Now I'll ask you to write an algorithm for checking whether there are any duplicated elements in the array or not. We have to see. So this is the simplest problem, and the answer obviously what it will be? It will be the exhaustive searching for the duplicated element in the array. What do I mean by this? So for each input element, we will check whether there is an element with the same value or not. So we can solve this just by using two for loops, and it can be written like this. You can see here, with using this two for loops with I and j value, I started equating. If at all both values are equal, I'll say duplicates are present and I'll print that value. Otherwise, if they are not equal, then I'll say there are no duplicates in the array. Simple one. So then the time complexity of this particular algorithm, I have shown you. If there are two loops, how to calculate? Initially we have discussed in the class. So that is big O of n square. Right? So for two nested for loops, this is the time complexity. And the space complexity will be big O of 1. So now if I want to improve the complexities of this particular problem 1, how can I do that? Only thing is, as there is an unsorted array, it was taking big O of n square. So to reduce or to improve the complexity, I will sort the given array. So after sorting, all the elements with the equal values will sit adjacently. So now just we do one more scan on the sorted array and we see if there are elements with the same value and the adjacent. Okay. So what modification we can do? I am writing with the red ink here. You can see. I will call the sort function. I will give the array first element and the total number of things. So I am sorting the array here, and then I will continue the same process. So then the time complexity will be modified to n log n. So I have improved the time complexity like this, simply by adding one sort function. I am sorting the given elements, then I am finding whether both are equivalent or not by seeing the adjacent places. So this is how we have to modify our approach in order to change or improve the complexity of our problem. Okay. Is there any other way of solving this problem? Yes. This is not only the one way. We can use hash tables. So interested students can refer to this. We have a hash tables concept. We can use hash tables. These hash tables are simple and effective method to implement the dictionaries generally, and the average time to search an element is here big O of n. In worst case time complexity, it is big O of n. Okay. For example, if we are having an array, when I am referring to the hash table technique, so if my array is having 3, 2, 1, 2, 2, 3, and we scan the input array and we insert the elements into the hash. Okay. For the inserted element, we put the counter as 1. Okay. I initially assume that all entries are filled with 0. Okay, then that if the counter is kept as 1, this indicates that the corresponding elements has already occurred. So for the given array, for this array, the hash table will look like, after inserting these elements, it will look like this. Okay, now if we try to insert 2, here we are having 2. So if we try to insert 2, then since the counter value of 2 is already 1, okay, we can say that element is appearing twice. Okay, like that we can change. By doing with the hash function, I can reduce the time complexity to big O of n and space complexity to big O of n. Okay, and even more I can improve this particular problem if I can do it like, I'll put the elements in the range of 0 to n minus 1. For each element of array, I'll go to the array element whose index is like I value I'll be maintaining, and I'll be dealing with that. Okay, but think about this problem. How can we modify more? It's a task for you all. Complete it, where the time complexity should be big O of n, only one scan should be there, and space complexity should be big O of n, or 1 you can put. Okay, this is a simple task for you. You can complete in the next laboratory session. Now, one more problem we are discussing here. One is, suppose I have an array with n numbers. Okay, now I'll ask you to write an algorithm for finding an element which appears maximum number of times in the array. So how do we do that? So for this, one simple solution is, for each input element, we check whether there is an element with the same value. For each such occurrence, okay, we increment the counter. So each time what we are doing, we check the current counter with the maximum counter, and we keep on updating it. If this particular value is greater than the max counter, then we can consider it like that. Okay, so we can solve this particular problem by using two simple for loops. Okay, how do I write? Come on, meanwhile, by the time I am writing here, when you are listening to this video, you have to write it in your paper. Try it. Okay. I need an input array, an array as an input, and the number of elements, and this will be returning some values, so integer, and I said like I will be maintaining one counter. For each element I will check whether there is an element with the same value or not. If at all further such occurrences, I will increment the counter, right? So I need to define or declare one counter variable and initialize with 0. And I need one maximum variable, and I will initialize with 0. Okay, I will use two for loops for doing this work. So I starts from 1 and it will go till n. I start with 0 and it will go till n. Then that is the stopping condition, right? You know it very well. So my counter initially is 0, right? Then I'll put one more this one. My condition is this. Then here what I will do, I will check whether there is element with the same value or not. So for that I will use if. I will put like ith element is equal to jth element or not. If at all it is equal, I will increment such, for each such occurrences I will increment the counter. Okay, then I will check if the current counter with the maximum counter, I'll check it and I'll update it, and I'll update if at all the value is greater than the max counter. For that I have to write like this. I have to see whether my counter point is greater than the max, then I have to update the max to says counter to max, then end it and I will return the maximum value. So when I return the maximum value, it means that I am finding the element which is appearing maximum number of times in the given array, right? The time complexity for this particular algorithm is big O of n square, and the space complexity is big O of 1. Same way, yes, we can improve this particular solution by sorting the given array elements. So after sorting all the elements, we will find the equal values will be coming to the adjacent. Now just you have to scan again the sorted array and see the elements appearing in the maximum number of times. Then if we apply the sorting techniques, then my time complexity will be equal to n log n, and space complexity will be equal to big O of n. Okay, even this particular solution can be used by applying hash tables. We can improve this solution by for each element of input we keep track of how many times the element appeared in the input. That means the counter value represents the number of occurrences for that element. Then when we use hash table, the time complexity will become big O of n, space complexity will become big O of n again. Okay, these two problems comes under search techniques. Generally you can these type of questions will be generally expected in the algorithms as far as a searching topic is concerned. Many more are there. How to find the missing values, how to find suppose a given array of elements, you need to find the first element in an array which is repeated. So for that also we can write. So think about these problems, okay, and be prepared for the exam. So I'll end this video here. In the next video we will discuss the sorting techniques.